So my name's James Tan. I've been using Unreal Engine since Unreal Engine 1, so that was about 13 years ago. So here I am today talking about UDK and how to develop an RTS game for the mobile platforms. So together with me I've got Marcus Arvidsson. So he's from Toyota Studios. So he'll be helping me out today as well. All right. So I'll just start by showing you the RTS game running on the iOS. So you sort of get a good idea of what we're going to be looking at, what we have developed over the last couple of months. So we've got finger touch controls to use so you can pan the camera, and you can use both fingers to zoom in and out. And you can also build some stuff as well. And we do also have some AI down here in the bottom corner of the map as well. And they're capable of building units, harvesting resources from these crates down here, and they'll start to build some barracks and they'll start to build some units as well. So what we're going to be talking about today is looking at sort of the problems about developing, when it comes to developing an RTS game, and how Unreal Engine resolves all of those problems for you. So it's really to break away from the perceptions that Unreal Engine is only for first-person shooters, it's only for third-person shooters, but really it can be used for any type of genre. So we're just going to stop that, and we'll switch over to the PowerPoint. Could I get that on both screens? No? Okay. So as I elaborated just before, so Unreal Development Kit, which you can download from www.udk.com, it's not just for first-person or third-person shooters. So even though you've seen it used for things like Infinity Blade, Unreal Tournament 3, Gears of War 3, it can do every kind of genre that you can think of. So some of the games that you may not realize that is built on Unreal Engine and that aren't first-person shooters, you got the new Mortal Kombat built on Unreal Engine 3, and you've also got an indie developed title called Rock of Ages, and that's also built on Unreal Engine 3 as well. And lastly, you've also got Shadow Complex, which is a side-scrolling game that was released a couple of years ago. So therefore, Unreal Development Kit is really well suited for developing RTS games as well. So the first thing is we're looking at the mobile platforms, and most of the mobile platforms that we have today are all touch-based kind of input systems. And so how do we handle those in Unreal? So Unreal gives you toggle inputs using Kismet or using Unreal Script. And it does this for Unreal Script, it does this as a form of a delegate, which is a function that you can override and call in other classes. And that allows you to receive, handle, and discard touch events at your discretion in Unreal Script. So one of the big things about developing the RTS was the order at which we handle the touch events. So as you're touching the screen, you have to figure out what do we want to do with that touch event. So when I built up the list, I said, okay, so first of all, we're going to handle the HUD elements. So looking at the buttons, the minimap, those sorts of things. If none of those things were touched, we then looked at the actors to see, you had to figure out, is the user touching an actor? And if he was, then what do you want to do with that actor? So this would handle things like moving players around, or moving the pawns around that represent the units in the game, or selecting a building and moving and setting rally points on them, or giving orders to them. And if none of those, if the user didn't touch any of those structures or units, we then looked at, okay, so he must have touched somewhere within the world. And if that happens, you then go, okay, let's look at panning the camera, let's look at zooming. So when you receive touch events in Unreal Engine 3, it comes to you as the screen space coordinates. And so on the iPad 2, they come to you as from 0 to 1024 in the width and 0 to 768. So the first thing that I had to do was translate these screen space coordinates into world space coordinates so that so I could actually handle the two things later on. So I had to handle whether or not the actors were touched by the user or whether the world was touched. With the HUD, you can still use the screen space coordinates. So the first problem is, how do we resolve screen space to world space? So this is done by using conversion. So there is actually a native function in Unreal Script which allows you to convert from screen space to world space straight away. So, and again, this is a good demonstration of the kinds of things that the engine developers have already thought of at Epic. They thought, well, what happens if somebody wants to do this? Okay, let's add this. And what that function returns to you is the space origin and the world direction. So if you imagine the camera is up here and the world is sort of flat as a plane down here, it projects out a frustum of where you're looking at. And what this function does is that it gives you a point somewhere within that 3D, within that frustum, and says, like, this is the direction where if you do a trace, that's where you're going to find stuff. So just a show of hands, how many of you guys have actually looked at Unreal Script, delved into that already? Just so we've got one, we've got another person down here, another person here. So just to let you know, the deproject function is available in the canvas and the local player, so you can use it in two different places. For those of you that haven't used Unreal Engine 3, the canvas represents the screen space of which you can draw things on, like widget elements, text and things like that. And the local player sort of represents the player. So basically, what I mean by this is that you can pretty much, in any case, use it pretty much anywhere, this function. So you can say that I have a point on the screen, I want to convert this to world space. You can do that at any time. But for those who have used Unreal, try to use the canvas method as much as possible because it's much faster. So as I was saying before, once you use the deproject function, so if you've got a screen, and so if you imagine the screen is the top layer up here and you imagine the plane is down here, the deproject function will return a point somewhere within that plane up there which represents the screen, and it gives you a world direction. And that way, if you do a trace from the point up here and you do a trace downwards, that's going to intersect with the plane which represents the world, or other actors within the world as well. So that's how you solve those problems. So basically with that, I was able to use the native functions in the engine, and I didn't have to write any of my own logic code here or anything like that. So the next thing is, once we start to know, okay, so this is how we convert the screen space to the world space, so how do we use that information to handle the panning of the camera, to move the camera around? How do we do that? And it's a little bit different on the mobile platform. Generally what people expect from a mobile platform is that they expect to be able to touch an area. So if they touch an area, then they expect to be able to move that area as they're panning it around with their finger. So you can't just sort of, say that if you move the camera to the left, the camera just moves to the left, because you get all these weird inverse controls, and it's just not an intuitive way of doing things, unfortunately, on the mobile platform. On the PC platform, that's perfectly fine, because users on the PC platform don't expect this kind of panning around with a finger. They generally expect you to just move the mouse to the left or to the right and to pan the camera to the left or the right. That's not quite the same way. So how do we go about doing this? So the first way I did it was that using the trace and panning and tracing down, I find the point in the world of where the first trace was. And as I move the finger around, the trace then sort of follows the camera. And then I find the difference between those two camera points, between the two different touch points, and sort of I add to the camera how the camera is being panned around the screen. So it's a little bit hard to wrap your head around, but the source code will eventually be up on the UDN as well, so you can have a look at it there as well. But that's sort of how I did it. So with the camera zoom, unfortunately we don't have a mouse on the mobile touch platforms. So I use the standard zooming out function like this, which is a really, really standard kind of control on the iPad too. It's what everybody uses to zoom on the photos, and probably most other applications support that as well. So with Unreal, you can receive as many touch events as you like. So every time a user touches his finger or her finger on the touchpad, that will send you, Unreal will tell you, it will say, hey, the touchpad has been touched. If the user presses a second one, another finger on the touchpad, another touch event will be received as well. And within those touch events, you get handles as well. So this will return a handle of 0, and this will return a handle of 1. So as the user is independently moving the fingers around, you can keep track of which fingers are actually moving around by using these handles. So the way I did the zooming was, I have 2 points. So if you imagine this is the touch screen here, so I have 2 points, and as the user does this, I measure the distance that the user is moving the 2 fingers. So as the distance is getting smaller compared to the previous frame, I zoom the camera out, and as the distance is getting further, I zoom the camera out. As the distance is moving in closer, I zoom the camera in. And that's a really simplistic way of doing it. You can make it a little bit more complex by also involving panning the camera as the user shrinks the screen. So as the user shrinks the touch event, you can say the camera should be panning to about here now. So if the user decides to pan the camera by shifting it like this, you can do that as well if you wanted to. But I found that panning the camera using that center location wasn't very handy because usually most users expect to do one function at a time. They don't really want to zoom and pan the camera at exactly the same time. However, the 2 code branches do work independently of each other. So if I was using 2 fingers to control the zoom like this, I could use this finger to also pan the camera as well. So the next step after I've handled the camera is giving units on the screen, how do we issue commands to them? And I did this in the following steps. So the player controller is an actor in the world which acts as the bridge between the input and what's happening in the world. So as the user pushes buttons, or in this case pushes the touch screen, the player controller receives this first. He then processes the inputs, and then you can decide what to do from here. In this case, I've got C and S in brackets, and this represents client and server. So we're going to look straight into the networking side of things straight away. And this is really important because you want to build your game regardless of, if you definitely know that your game is going to be single player, you can decide to forego this and build it in another way. But if your game may possibly be multiplayer, you probably want to set this up right from the start. So what I did here was that the client-side version of the player controller sends a command to the server side for the player controller. And then the server-side player controller then says to the unit that was touched, here is the order. The reason why you can't send the server command to the client command straight to the server-side actor is because Unreal has security checks along the way. If you don't own that unit, then the server says you don't own this unit, so you can't send commands to it straight away. So it's a security check, basically. So as I was saying, this whole thing was required for replication purposes. So in order to get this RTS game working multiplayer-wise, I had to go through player controller client, player controller server, then player controller server to the AI controller on the server side. And the AI controller then tells the unit, okay, move here, attack this thing here. So one of the things that Unreal does as well to reduce the bandwidth used in multiplayer games is that it only sends what it absolutely needs to each client. And we call this relevancy checks. So if we put an example, in Unreal Tournament, for example, you might be here and say Marcus is another player, and I can see him, so he's relevant to me. But if Marcus was outside the room, Unreal would say, Marcus is no longer relevant to me because I can't see him, so I can't interact with him. So one of the things that you have to be really careful about when you decide to build an RTS game in UDK is that you have to decide which actors are actually relevant to the player at this given time. So if a unit is a million miles away from the camera, is that unit relevant or not? And that kind of depends on your situation too. So I got this gentleman here just shook his head, and you're right. Sometimes if the unit is a million miles away and if he's in fog of war, it's not relevant at all to you. But if the unit is a million miles away, but you can see the unit on the minimap, it then becomes relevant because even though you can't see him on the screen, you can see him via the minimap. So it kind of depends. And you can adjust relevancy by using various parameters, like Boolean flags in the actor. And, or you can send raw commands back to the client to say, this is the unit's coordinates, or this is what the unit is doing at this given time. So this is a kind of a general problem in most strategy games, is how do you position units in a game? And basically, unit positioning is really, really important. So if a user says, I want the unit to move there, and if the unit decides to move that way, for example, and there are like turrets and stuff all through here, that's not really good, because then as that unit moves towards that location, he's going to get shot up and stuff like that. Ideally, you want him to move down that way, or running through cover or whatever else. And that can make or break your strategy game. So how do we solve this kind of problem in Unreal? So what I often do is do lots of radial checks. So as the unit is moving, he sort of does a fake radius check around himself to figure out, what am I sort of approaching? Am I approaching something that's going to kill me? Am I approaching something that's going to be friendly towards me or give me a boost? Or am I going to be walking through an area which will damage me? Those sorts of things. And then you can, it's often a try and retry sort of algorithms to attempt to find really good positions. So as the unit is moving down and he's forward looking and he does a radial check and he says, something is here and that's going to damage me, you might want to start saying like, okay, go a slightly different route. And you can do this by adjusting some of the parameters in the pathfinding algorithms that are available in Unreal. So Unreal, in this case for the RTS game, I was using some technology called the navigation meshes. And what these navigation meshes are is that they're sort of like a polygonal representation of the world as such. So if we're looking at this room here, you would see lots of polygons between the tables and things like that. So as the unit is told, okay, I want you to go to the end of the room, he sort of checks through the polygons to check, how do I get there? And so what you can do is you can add some constraints to different polygons in the world to say, avoid these polygons as much as possible. In this particular RTS, I avoided the pawns from blocking each other. So that is, if two pawns are coming together and they're moving together, if I didn't have any algorithms in place, they would actually just run right through each other. And the reason why I did this is that it tends to cause lots of problems if they can actually run together and then sort of hit and touch each other like this. And the reason for that is, as they're running together, one of them will try to jump up and the other one will try to jump up, and basically you just lead to really, really funny situations where you've got units doing this sort of thing, and they just climb up and up and up into the camera, which looks really, really funny. And if they're also running to a similar destination, that unit wants to move that way, for example, and that unit wants to move that way, they just end up doing this, and they just end up going, that sort of funny feeling where you see someone in front of you and you're doing this and he does that and then you're doing this, and it's the same kind of thing. So it's actually much better for the units to just sort of run through each other. But if you have algorithms in place, you can make them sidestep slightly. So as they run through each other, if the mesh is just sort of offset, they just run right through each other. You avoid all of those problems straight away, basically. And it ties together with the unit positioning as well, because you don't want units getting stuck, because then players are just going to look at the game and be like, this is really frustrating. Why are my units getting stuck into each other? So we're going to talk about structures and how I handled that inside the UDK RTS game. So structures are just an actor. And one of the really good things about the navigation mesh as compared to using path nodes is that you can actually place dynamic obstacles within the navigation mesh. So if this table here didn't exist before, there would be polygons there to say that I could move through that area. But as a structure gets placed down, it'll say, I want to carve out an area within the navigation mesh and take that out so that units won't try to run through that area anymore. You couldn't quite do that with path nodes because you couldn't quite predict exactly where players were going to be placing their buildings and things like that. So navigation meshes here was a really good technology that resolved this problem for me straight away. So one of the things that you're going to be really aware of with dynamic navigation mesh obstacles is that you want to keep them as simple as possible. You want to keep them something like squares, triangles, or as complex, something as a pentagon. That's about as complex as you want to go. You can make it as complex as you want. There's nothing to stop you from doing that. But you don't really need to divide up the navigation mesh a million times. So for example, if you have a nice polygon like this, you don't want to place like a 64-sided circle in there because that'll intersect lots and lots of times with the triangle edges. Because then that'll just make the navigation mesh too complicated. And there's really no benefit. You don't gain any benefit from doing that. But if you just make it into a square, you reduce the number of intersections that you make within that polygon. And it gets more complicated once you start having really, really complex maps as well. So if you just make it into a square, it's nice and easy. For example, this table here, it has rounded edges and things like that. But there's really no point for me to say, let's place a navigation mesh obstacles and have all these rounded edges because I don't gain anything from doing that. And plus, if you make it really simple, the update times are really quick as well. So the other thing about structures as well is that you also want to place, you can use volumes, which are invisible BSP inside the maps to prevent players from being able to place buildings there. So for example, if you've got a river, you can just use a simple volume to say, you can't place buildings in here. And you can also use area detection as well. So if I build a building here, that can emit sort of like a radial check. So if the player just, tries to build a building there, that building will say, no, you're too close to me, you can't build that here. And the radial checks are exactly the same as the unit checks, the unit radial checks. It's the same kind of algorithms I use there. So in Unreal specifically, you can use iterators that will iterate through the whole actor list within the world, or you can use different types of iterators to try to find which actors are nearby this particular location in the world. Okay, so the next thing we move on to is AI, and how did we solve that in Unreal? So Unreal uses two actors to control one actor in the game. So one actor in the game, which would be the physical representation, say me, that would be the pawn. And that's the actor that most Unreal games will be using. And then they have a controller, which is another actor. And the controller would be sort of like the metaphysical representation of me. So the pawn would have things like the skeletal mesh to represent the body and things like that. And another actor, which would represent, I don't know, like my soul, for example, it would then send the commands to the body to say, this is what you want to do at this given time. And the reason for this setup is that you can reuse and pull those types of actors together. So you can save on a lot of memory by doing this. So say, for example, how many of you guys are engine programmers as well? You got one, two? Okay. So one of the things about memory is that you want to reserve chunks of memory to do things. So you want to say, this chunk of memory is for all pawns, this chunk of memory is for controllers. And if you don't do that, what happens is that if you spawn pawns and controllers, at any given time, you end up with a lot of memory fragmentation. And this type of setup helps resolve that situation. So if a pawn dies, you can just make it disappear and teleport him somewhere else. And that controller can say, I'm no longer controlling that actor. And then if the player then rebuilds the same unit again, you can just teleport that unit into somewhere else, and that controller can take over that pawn again, for example. And if you have each unit to have its own AI, it can respond to local stimuli. So if, for example, the pawn is walking around and he sees an enemy unit, that his own AI will say, like, okay, start shooting at that enemy unit right there. Or he can say, there's a resource near me, so I'll start harvesting that, if I can harvest stuff, for example. Or if I can do something special, like do a skill that will wipe out enemy units in front of me, then do it now. So it also allows you to really fine control the unit AI as well. So you can make some units really expensive, but really slow in the way that they think. So for example, you can have like a massive tank that moves really slow and turns really slow and decides to do things really slowly without player input. And you can control how the AI, at what times does he think, okay, I got to do this thing now. Oh, okay, I got to do this thing now. For the AI that I had in that demonstration, it's another AI which is over the top of all the other AIs. So you have like a master AI at the top, and it sort of knows about all the little AIs at the bottom. And the reason for that setup is that that master AI can formulate its strategy against the player. So it can say, oh, there's a player down here. Do I really want to attack him? What's his military strength like compared to mine? So the AI would then go, okay, so I have these 5 units, and they're kind of of this particular strength. So I add all of that up. If I was to attack that player, would I be able to beat him? And the answer may be yes or no. Or that AI can go, okay, what are my goals right now? Okay, I have very little cash, so maybe I want to go harvest something. So all of my harvester units should go down here and harvest all of that because it's safe. So, and basically having this master AI controller basically prevents you from having every single AI unit from having to communicate with each other all the time. And that really helps as well because then since this master AI controller knows where everything is, it can say, okay, these group units move down here, harvest these resources, these units over here, go over here and start attacking this enemy player over here. And that was the general setup that I used for this RTS game here. So one of the things that you're going to have to do is that a lot of your units are going to have to be able to report back a lot of metrics. So if the master AI says, okay, so what gun do you have? And the unit would say, oh, I have this gun, and so forth. So things such as strength rating, speed rating, how fast this unit is, and so on and so on. So another really important aspect is that you need to provide the appropriate feedback when you're using a mobile device. Because one of the things is that units are going to be in front of the finger, or they're going to be behind where the player is pushing. So, if you just imagine this is a big finger, the unit is here, he's going to be he's going to be touching that unit and moving that unit down there, or panning the minimap and so forth. So you got to remember what kind of feedback responses can you give. So one of the things you can do is playback sounds, and of course Unreal Engine resolves that really, really easily for you. So you can just import WAV files in, and you can decide when you want to play those. You can also decide to which clients you want to play this sound back on as well. So if a unit is being moved down here, the unit will want to say something, and you can say that, okay, when Unreal plays this sound back, only play it to the player that actually owns that actor, or only play it to that only play the sound back to the player that matters, or to the team that matters. so that every other player knows what that player is doing. But you've got to remember that some people who play mobile games have the sound really, really low as well, and or a very quiet level. So sound is not the only method that you can use. Yeah, another method you can use is particle effects. And I actually use particle effects as well when you move around units. It shows the little arrows going, I think it shows little circles going around like this. And it's to sort of notify the player that, okay, yeah, you've told a unit to move to that direction. And particles are really useful because they can persist over a couple of seconds. And the really nice thing about Unreal Engine 3 is that you can make all your particles inside Unreal Editor. There's no need to go, into another content creation package. You don't need to do any of that. And that way everybody can tweak with these particle effects and how they play back. But you got to remember, do they cover the whole screen? Do they, or what do you want to do with them? Will they still be visible where the finger is? So if I tell a unit to move down here, and I release the finger, when it plays back, is that still going to be visible to the player? And those are some of the questions that you're going to have to design through. And the other one is a HUD response. So as you move that unit down there, does the HUD actually flash? Does the HUD do anything? And again, Unreal really helps to solve that problem really easily because you can draw textures on the HUD, you can draw materials on the HUD. So it just makes it really, really easy. But again, the question is, will they still be visible where the finger is? So the other thing you've got to be really careful about when you're designing mobile games is that Unreal gives you a lot of power in deciding where things are going to be placed, where you want to draw things, what widgets you want to draw, when you want to draw them, at what opacity do you want to draw them. But the thing we've got to remember is that given all that power, you've still got to be really careful what's up on the screen because you've got a certain amount of resolution on the touchpad, you've got a certain amount of real estate there. So if you draw too many things, it's going to clutter up the visibility of what's happening in the game. So one of the nice things, as I was saying, is that you can draw things at different opacity, and all you need to do in Unreal is basically tell it a value between 0 and 255 and just say, here's this value. And Unreal will just draw it at that value for you. It will just say, okay, this thing is transparent. It will just do that for you. Or you can feed it into a shader, and then Unreal will just draw that shader at half opacity. And that's really nice. And the other thing is that even though you've got a really nice resolution of 1024 by 768 on the touchpad, you can't just make things smaller and smaller and smaller because the user at the end of the day is still going to be using his finger. And unfortunately, as much as I've tried, my finger it's not as accurate as a mouse. I think I don't have any fingernails, so I think it just can't be as accurate. So if you make things too small, then it just gets harder and harder to touch those things. Okay, so we're coming to near the end of the presentation. So one of the things is that as you use UDK, you're going to need to say, okay, so you're going to need a little bit of help. Where can you go to get help? So one of the things you can do is jump on the forums, and the forums provide you a lot of feedback. You can ask a lot of questions there. So usually I'm on there providing as many answers as I can. And there are a lot of veterans who use Unreal Engine on those forums as well. And that's the site there. And there's also the UDN as well. And that's completely dedicated to talking about giving documentation on Unreal Development Kit. There's also lots of really good tutorials there as well. So there's a section called the Development Kit Gems, and that provides you with solutions of how to do things. And it's also been constantly updated with new documentation and things like that as well. And that's the website there as well. Okay, so we've got about 25 minutes. If any parts of the presentation that I've done today have sort of been a little bit too quick or I haven't explained it well enough, just let me know now and we can go back to those slides and I can reiterate again. So did anyone have any difficulties with any of the slides there? If you can just sort of ask the questions to the microphone, that'd be really good.
When you were talking about the nav meshes,
yes.
Can you attach separate nav mesh pieces to an existing mesh so you'd have a more complicated structure but a more simple nav mesh?
I'll just go back to the page where I talked about navigation meshes. Okay, so the quick answer to that is depending on what you would like to do. So as in you have two separate portions of the map and you want to join those navigation meshes together?
No, just so that if you have a structure that might be like a pentagon or hexagon or some complicated shape and assign it a basic square so that it occludes around the square piece and doesn't actually try to find each of the small bits inside. So you can have a really complicated structure, but still walk around it in a basic square form.
Oh, right. So dynamic navigation mesh obstacles can be any type of shape that you want.
Yep.
So regardless of the actual structure's mesh, it's not based on that.
Right,
so
the nav mesh is separate.
Yeah, that's
awesome.
Correct. Yeah, so what you can do is, so what I did specifically in the UDK RTS is that if I had a structure of any particular shape, I would spawn a new obstacle on top of that, and that obstacle itself would say, I'm a square, so just leave it at that. And that's what I did there. Yeah.
Well, in Montreal, it's hard to find someone to give us like some training in Unreal. We did an Unreal game with UDK, and even with the forum and all that, it's always helpful to have someone in-house to help us, develop and everything. So do you have some resources we could go, or people in Montreal that we could go to find some help for specific need with Unreal?
Unfortunately, I'm not entirely sure, unfortunately. I could probably best answer that question just after this talk here today.
Okay.
Yeah, we'll just go over this presentation today.
Okay, and for the presentation,
sure.
When we did our game, we had lots of difficulties with the memory management for the particles.
Okay.
How do you handle it with a mobile platform? Because the resources are so the limit is so low, like even a little spark of fire would buzz the memory. So how do you handle this?
Okay, it really depends on the fire. What I did with the UDK RTS was that I made sure to use the minimum number of particles that I required for the effect intended. So as units were shooting, if I could get away with just using one sprite emitter, that's what I would use. If I could get away with composing the sprites together, I would also do that as well. So often with the UDK RTS, if there was a fire there, for example, you could build it using several sprite emitters emitting different sprites and things like that. But sometimes it was just easier just to animate the sprites as sort of like textures, individual textures as well. And that's some of the tricks that you can do as well. And again, Unreal is really useful in that aspect because with the particle emitter cascade editor, you can actually say these are the list of sprites that I want you to play at these particular intervals. So if you minimize the number of objects that you use, it'll help a lot with those sorts of things. Yeah. Another thing that you can also do is by reducing the texture memory that was used. So one of the things that Unreal really helps with, particularly on the mobile platform, is that you can just say all of the sprites that are emitted by this particle sprite should just be gray in color. And then in code, you can actually just tell it, here's the color I want you to actually play back at. And so it would overlay that color on top of that grayscale sprites, and that would end up being the color. So for example, if I had a red unit and a blue unit, and they were shooting each other with their guns, you expect some muzzle flash. So the actual muzzle flash textures were all gray, all black and white. But the game itself would say, I actually want you to be in red, and it would just tint those grayscale sprites into red. And that's another really good way to save on texture space as well, which is really important on the mobile platforms. I guess just...
So our team has actually been working on an RTS for some time now, and we hit on two of the issues you talked about here.
Okay.
The first was with HUD. We used Scaleform for our HUD, but we had to kind of use some kind of hacky stuff to manage getting input there and making sure it doesn't pass on to actors in the world and make sure it stops at Scaleform. I don't know if you chose to use Scaleform in the way you did it, or did you use a different approach?
I decided to use the canvas in this particular respect. I just found the canvas much easier just to draw the widgets on directly. I could also scale and change because the minimap that you saw in the presentation, you can actually, the little triangle in the bottom left-hand corner, you can actually touch that and drag it around. So basically, I just ended up using the canvas because it was a lot easier for me to do so. And as I was saying earlier, when it came to handling the touch events, I first checked against a list of the widgets on the screen and just said, did the HUD actually handle the touch event or not? If it did, then stop here. If it didn't, then it would carry on.
The only other thing was for nav meshes.
Yep.
We found some weirdness when we were generating nav meshes with height differentials in maps. Anything used stairs, and on the PC side of it, if we did anything with landscape or terrain, the nav mesh generation became way too complex. Mm-hmm. And units would navigate really strangely and get into strange loops.
Right, so this comes back to the unit positioning, where, well, actually, more the constructing structures. This is where you could use things like volumes to help start, because the really good thing about nav mesh is that it traces every single polygon everywhere. And one of the things you can do to simplify things is to use volumes, such as blocking volumes or path blocking volumes, or nav mesh volumes as well. And that helps to suggest to the nav mesh how it should be generating. So, for example, if you have, say, a rock and it's really rocky and stuff, nav mesh is good in that it goes in between all the crevices and things like that. But that kind of detail is not really required. So you could just add a volume there to say, this is just a straight edge as far as pathing is concerned. For stairs, you can use a sloped volume, and you can just say that, the individual steps don't really matter overly too much, and that it's just really the slope of the stairs that you actually care about. And it's sort of relevant to how structures are done as well, and that you don't need to use a pentagon or a hexagon to represent the structure on the nav mesh, but a square is usually more than adequate, so that units can just route around it. So
thanks.
Okay, you're welcome. So I can just elaborate on some of the metrics that I also gave out in my UDK RTS game. So not only did I give the strength rating, although strength rating is really difficult because you can adjust that based on various parameters. So one of the things that I wanted to do to evaluate the strength of a pawn was its current health state at the moment. Did it have any effects placed on it? So if you're making, say, a fantasy kind of game, you might want to say, is this unit being slowed down, or is this unit being crippled, or anything like that. So those were so that was one of the metrics that I used. The other metric was the speed rating. So obviously there's a baseline value that you want to say that an average unit will move at, or what is considered to be a fast unit. So the unit can say that I'm 50% below the average, or I'm 50% above the average. And so by using from 0 to 1, you make it a really nice, simple value to evaluate. The other types of metrics I also used were things like how strong the weapon was that the unit was using. And once you collect all of those ratings together, you form a really simple value for the AI controller to say, okay, these units should be used to do this particular task, or these units should be used to do this particular task. Oops. So I can also reiterate over just the handling of the camera as well. Not only did I didn't just have the panning of the camera as well. One of the nice things that I found that I could also do was have these really thin strips on the side of the HUD. And as the user moved his thumb over the side, it could actually pan the camera to the left or to the right, or north, northeast, southwest, and things like that as well. And the nice thing about doing this in Unreal is that it's really easy to feed that through the HUD, because I'd set up the system previously. So these are just transparent bars along the side. The other experiments that I also did with the camera zooming as well were things like double tapping. So if you double tapped onto an area, it would just zoom up into that area. If you double tapped again, it would zoom out from that area. And the other thing that Unreal does when it sends you those inputs is that it actually says, the input started at this particular time. So you can sort of compare times between touches and things like that to do things like double taps as well. So if you wanted to add some time-based mechanics into your RTS game, for example, if a unit was to use a skill and it required units to touch things at different times, at different points, you could easily do that using the touch system that Unreal exposes to you. I'll just elaborate over the unit commands as well. One of the things that you don't have to always use this particular setup. If you were making an RTS game which wasn't multiplayer at all, you could route straight from the player controller straight to the pawn AI controller without assuming, this player controller is client only, this player controller is server side only. You don't have to worry about that at all. So this setup was used for security reasons to make sure that players couldn't do things to cheat within the server side or anything like that. So another thing that I can elaborate over the unit positioning as well is that you can also run reasonably complex algorithms. One paper that I studied was called Reciprocal Velocity on Moving Obstacles. And basically, you can feed some numbers into it, and it will return good velocity values of how units should be moving around things. So, for example, if you had two units moving this way, you could feed the numbers into this algorithm, and it could say that these units should be sort of dodging to make sure that they don't collide straight into each other. So there's a lot of power that you can use in Unreal Script. So how many people have actually heard the assumption that Unreal Script is 20 times slower than C++? Okay, so one person has heard that. It's often a comment which people say, but I think if we crunch the numbers, how fast is C++? It's pretty fast, right? So even if you say it's 20 times slower than C++, Unreal Script is still pretty darn fast. The equivalent sort of analogy that I like to use is that my car at home is about 1 billion times slower than the speed of light, but it's still pretty fast when we think about it like that. So with Unreal Script, you can still use and do complicated algorithms such as the reciprocal velocity-based obstacle checking as well, and that can help with the unit positioning of how you want units to move around things as well. So I'll just elaborate over the AI as well, of what I did with the team AI. So this team AI is sort of controlling all the other smaller AI. And often what I would have is, sorry, so we've just got 10 minutes. The other thing that the team AI can also do is have like a build plan. So what I did with the UDK RTS game was that I actually had an object which contained lots of data that level designers or game designers can input into and say things like, I want you to build this structure before building these sets of units, or I want you to start harvesting if I go below these number of resources. So Unreal allows you to do this type of system because it has something called archetypes. So what archetypes are is that they're instances of objects that you create. So you can create a class in Unreal script, say called data. You can then create an instance of this object inside Unreal Editor. And what that would allow you to do from there is that inside Unreal Editor you can start modifying the types of variables that you want. So you can add a command inside that data object to say that this AI should be doing this at this particular time, or this AI should be doing this at this if this happens, and so on. And it provides a really nice interface for game designers to be able to modify how AI should behave. So just to elaborate on how UDK was explicitly useful in this particular case. So the first thing is that UDK solves a lot of problems for you. It solves how you should render things onto the screen. It also solves things like sound playback. It also solves things like networking as well for you. Changing it from the traditional first-person view to the third-person view is also really simple by moving where the camera is and pointing it, because in Unreal Engine 3 there is literally a camera actor which says this is where the camera should be within the world. And you can just say the camera should be up in the sky and it should be looking down at the ground. So in order to do that was quite simple. And as I elaborated earlier on, you can then use the deproject to go from screen space into world space using the traces. And that allows you to figure out what the player is wanting to do at any given time. Is he wanting to move the map around? Is he wanting to select a unit and touch and move them there? Is the user wanting to select a structure and build some units or something like that? From a game designer point of view, Unreal also provides things like Kismet as well. So Kismet is built on top of C++ and Unreal Script. So you could create new Kismet nodes which would allow you to do things such as scripted events. If the player moves 5 units to this particular area, then perform this Kismet event. So I did do a little bit of that inside the UDK RTS game. And again, it was really easy to use that system as it was based on Unreal Script. Okay, so just to elaborate on a little bit more again on the touch events as well, is that since Unreal provides you these touch events as a delegate, you can actually pass that delegate to many different classes within the game as well. So you can have particular units responding to a touch event and deciding what to do with that touch event. So that makes it really, really simple if you have a unit which can perform something special, because you can directly feed it to somewhere. Okay, we've got about 5 minutes left to the presentation. If anybody else has any more questions, definitely now's a good time to ask them. So the performance metrics that I can give you about the RTS game running on the mobile was that I was able to get up to about 20 to 30 units on screen at any given time, which is pretty good on the mobile platforms. I was also able to get quite a lot of polygons onto the screen. I had done some benchmarks, and I was able to get about 30K to 40K polygons on the screen on the mobile platforms. And the performance metrics that I can give you on the replication side of things in terms of networking and multiplayer was that I didn't have too many problems having up to 3 to 4 players controlling units using Game Center. So okay, well, that's towards the end. That's about the end of the presentation. So I'll still be hanging around at the end afterwards. So if you have more questions, or if you want to see a live presentation of the UDK RTS game running on the iPad too, feel free to come up here and have a look. Cool. Thanks very much.